Right, so hey everyone. Today we're going to have a look at finding the side length of a triangle in trigonometry, right? So before we get into things, let's start off by drawing a right angle triangle so that we have let's say we draw our side length sides of the triangle. Our hypotenuse now, so let's draw our angle, which we're going to call theta. So all right, so what we want to do is to start off with, let's label our sides as either opposites, adjacent, or hypotenuse. So the side that's opposite the angle, because we're going to use our angle as our reference point, right? So the side that's opposite from the angle is our opposite sides, which we're going to denote as O, right? And then the side that stays right next to the angle is that's perpendicular to the opposite side of the triangle. So I should draw the right angle here. So right. So the side that's opposite the theta angle is what we call the adjacent angle. So we just denote that as A, right? And then the side that's the right and then the side that is the opposite of the right angle is, or the slope, is the hypotenuse. So these are our three sides of the triangle. So and our trig functions are sine theta, cos theta, and tan theta. So let's start off with sine theta. So we've got sine theta down, right? So to find sine theta, right, we need to use this formula: sine theta equals the opposite side, so that's this side here, over the hypotenuse, so that's the slope there. So the sine theta is going to equal to opposite over hypotenuse, right? So that's what we have here, and we also have the cos theta as well. So the formula for the cos theta is adjacent, so that's this side here, so the bottom side length right next to the angle, and then that's going to be adjacent over hypotenuse. So so the formula for cos theta, right, is adjacent divided by hypotenuse. And then we also have our other trig function, right, which is tan. So tan theta, to find tan theta, right, we need to do we don't use the hypotenuse to find the tan theta, so that we're going to leave that out completely. So to find the tan theta, right, we need to divide the opposite side, so that's this side again, divide that by the adjacent side, so that's going to be O over A. So yeah, and another way that you can memorize these formulas, right, is you can do SOHCAHTOA. So we will start off with the sine part of it. So we have SOH. So that means that sine theta equals opposite divided by hypotenuse. Then we have the CAH part of it next. So that means that cos theta equals adjacent divided by hypotenuse. So think of cos first, and then think of adjacent next, then hypotenuse. So by that I'm saying that cos theta equals adjacent divided by hypotenuse. Yeah. And the last part of it is going to be TOA. So I think you will get what I'm saying. So so another way of memorizing the trig formulas are using this mnemonic SOHCAHTOA. So SOH CAH TOA. All right. So hopefully this should make some sense now. So let's get into some example questions. All right, so let's do this first question. So we are going to work with the triangle on the left-hand side, and we're going to find x, right? So which sides do we know for this one, or which side are we trying to find, right? So we are trying to find x, right? And is x opposite, adjacent, or hypotenuse? X is adjacent, right? So we're going to label x as A. So we're going to put A in brackets just to indicate that A is the adjacent side from the angle, right? And as you can see here, let's write these right angles down. Like we should have found that earlier. So that's better now. So and for this one here, right? What is our hypotenuse? Our hypotenuse is 5, right? So let's put h in brackets just so that we know that it's the hypotenuse, right? So all right, so let's get into the question now. So for this particular question, so we're going to call this question 1, right? So we only know what we only know about the adjacent side and the hypotenuse of the triangle, right? So which sine function do we need to use in order to find the side length x? Well, we need to use the cosine and trig function. So we need to so let's write down the formula for cos theta, right? So we have cos theta equals as adjacent divided by hypotenuse, right? So we know what the angle is. So then it's going to be cos 42 degrees equals adjacent is just x, and then divide that by 5. Now, what we need to do is we need to get x to x by itself, right? So this leaves us with x equals 5 times in cos 42 degrees. So we'll just leave that as 5 cos 42 degrees. Then. And then plugging that into the calculator, we should get cos 42 degrees. Oh yes, so we then get rounding this off to 2 decimal places, we get about 3.72. So 2 decimal places. Also, another really important thing that we need to take into account is that we need to ensure that our calculator is in degrees mode, right? So I'm just going to type this down. So please ensure that your calculator is in degrees mode when finding side lengths in trigonometry. All right, so that's very important to remember. So please ensure that your calculator is in degrees mode when you're solving those sorts of questions. All right, so moving on to the second question. So we're going to call this question 2 for this one. So all right, so for this one, we know we have the opposite side and the hypotenuse. Right, so we'll label, we'll put O in brackets just so we know that it's the opposite side, right? And then we'll put H in brackets for the side length of 7 for this slope, right? So that we know that it's the hypotenuse. So. All right, so since we're dealing with the opposite side and the hypotenuse, right? we're going to use the sine function. So sine theta, if you remember from the earlier slide, right? So that's just going to equal to O divided by H, right? So, and then plugging our values in, so we get sine 27 degrees equals x over 7. And again, we need to get x by itself in order to solve for x. So that gives us with x equals 7 times sine 27. And then plugging this into our calculator, we should get 7 times sine. Oh yes, so we should get about 3.18 then is our side length for x, and that's just going to be in 2 decimal places. Yeah. And the last question we're going to deal with is, so we'll call this question 3. So before we get into the last question, let's do the same thing again. So we using our angle as our reference point, and we have 2 as our opposite sides. So denoting as O. Since this side is opposite directly to this angle here, and then x is adjacent to this angle here. So we're just going to put A here in brackets. Alright, so since we know what we're dealing with the opposite and adjacent sides, right? And then we're trying to find the adjacent side, and that we know what the opposite side is, then what we then need to use is we need to use the tandem functions. So we have remembering our formula from our earlier slides, right? We have tan theta equals opposite over adjacent. And then plugging our values in, we have tan 73 degrees equals 2 over x. So this one is a little bit different, but it's not too tricky though. It's just that we have x for our denominator instead of our numerator. So in order to get x by itself, we're going to swap the positions between x and tan 73, right? So in this case, that would mean that we have x equals 2 over tan 73 degrees. Okay. And that should give us 2 divided by. So that would give us about 0.61, and then for our x value, and then that's rounded up to 2 decimal places again. So good. So hopefully this all helps, and hopefully you've learned something from this lesson, and have a better understanding of how to find side lengths using trigonometric functions. And let's remember our trig functions, right? Sine theta being equaling to O over H, cos theta equals to A over H, and then tan theta equals O over A, or opposite divided by adjacent. And the easiest way of memorizing these formulas is using SOHCAHTOA. So SOH, CAH, then TOA. So hopefully, so I'm gonna end the lesson here, and yeah, let's and hopefully you can apply these formulas to find the side lengths of one of the sides. Hope that helps you guys. I'm going to stop there. So take care, everyone.